This is video number 2 from my my energy chapter, not my fitness chapter. So when we talk about the energy systems, like I said, you have two major ways in which you can make energy in the body. You can burn fat and glucose. You can do this indefinitely. Really, the only limiting step of you exercising is glucose. Once you run out of your glycogen stores, then you rely on fat. Fat requires a lot of oxygen to break down and to use the energy in fat to then import that or stick that onto ATP molecules. So you can continue to exercise when you run out of carbohydrate, but you just get really tired and exhausted. Runners call that hitting the wall. That happens at about the 2 mile mark for many elite athletes. So you don't want to run out of carbohydrate. Your performance will definitely drop off. So you got the burn, you got the convert, and there's actually a third system. They always call it 2+1. The third one is one that many folks may not use often. It's the creatine system. Some of you may have heard of creatine as a supplement. And what it really is not using carbohydrate or fat. It's essentially if you go to do something that's super intense, like throw a shot put, sprint as fast as you can for 10 seconds. That will drain your muscle of ATP, like all of it. But you do have this backup molecule, kind of like a backup battery for your phones. And it's called creatine phosphate. And what the body can do is rapidly break down the backup and to regenerate ATP. Most muscle tissue, like a bicep, a tricep, a quad, leg muscle, has about 10 seconds. Once you burn through your creatine, you really can't compete at that high level for many hours because it's not like glucose and fat and all that stuff where you have all these different ways to kind of move it around the body, shuttle it. You can sip on, Gatorade, whatever. Creatine kind of gets burned up for long periods of time. That's why when people like do sprinting events, they don't last, they'll do an Olympic sprint in the morning and maybe they do one late at night for like the gold medal round, but they do like one a day because it takes up to 24 hours to rebuild your backup battery. For glucose and fat, that doesn't take much time anyway. So there really are two major systems. This is kind of the third secret backup system. Now, where do you make energy in the body? There's different places. If you're going to burn stuff with oxygen, you burn that in little things called mitochondria. And this can be a nerve cell, this could be a heart cell. Let's just pretend this is your typical, bicep, big guns arm, The Rock, Dwayne Johnson, bicep. Inside muscle cells, you find these things called mitochondria. It's like a little baby organ of the cell. People used to call them organelles. And the way it works is you feed in glucose. That's where fatty acids go to get burned. That's where the muscle uses glucose to get burned. You enter in glucose. You enter in oxygen. Out comes ATP. It's not exactly that simple, but it's good enough for teaching purposes. If you don't have oxygen, you can't use the mitochondria. So all you can do is convert glucose in the kind of the big area of the cell, which is called the cytosol, and you convert that to lactic acid for 20 to 30 seconds until all that lactic acid in the muscle tissue starts to shut down the actual workings of the muscle cell. So you get two different places. One requires oxygen, the other doesn't. And another way to show this, and I know this is simple. I get it. I tried drawing this. It didn't work. This is my technology level. They used to say in the Army, you are promoted to your level of incompetence. This is my level of incompetence. So if we are aerobic, we're going for a walk around a track. We're breathing oxygen. It's getting into our blood supply. Oxygen is being carried by red blood cells to our muscle cells. The oxygen is being taken into the mitochondria. Muscle cells are receiving fat from body fat. They may have fat that's actually on hand in the muscle cell. Remember, muscle cells store glucose as glycogen, so they have glucose. They may be receiving glucose from the liver. Either way, they have these two energy molecules. They feed these into the mitochondria. Out comes a ton of ATP, and we do make an end product called carbon dioxide. That's where it comes from. Your mitochondria in your cells. And water. You actually make water in the body. So this is the aerobic way to make ATP just at rest, at moderate activity, 24 hours, 7 days a week, your entire life. You're doing this until the day you die. aerobically making energy using fat, glucose, and oxygen. That's the aerobic system. The anaerobic system's different. If you say now, instead of walking around a track, let's sprint around a high school track, right? The 400-yard, 400-meter track. By the time you're 20, 30 seconds into sprinting, your lungs are probably gasping. What you can take into the lungs drops off. What you can put into the blood drops off. What actually gets into the muscles drops off. If oxygen levels drop off in the muscle cells, you can't use mitochondria, which means you can't burn fat and glucose. Then how the heck do you complete that lap? Because most folks can sprint a 400-meter lap. They may be gasping for air once they complete the lap. They'll get around it though. I mean, they probably will. What the muscle tissue does is it sees there's an immediate need for ATP to keep running. It immediately goes into this anaerobic pathway, takes glucose, converts it to lactic acid, converts it temporarily, and then makes ATP. The problem is, as lactic acid builds up and other molecules, to keep it simple, we'll just focus on lactic acid, it actually kind of does a bit of a biofeedback and shuts the system down. So the reason why you can't sprint indefinitely is you'll start to get fatigued in the muscle within 20 to 30 seconds. You start to feel pain in the muscle in 20 to 30 seconds. And by 30, 35 seconds, your muscles stop contracting and relaxing. Literally, the mechanics of the muscles shuts down. And that tells you it's time to stop running and start breathing and transition back into an aerobic burner. So what happens to the lactic acid? Let's say you sprint a high school lap, or you're on the Sac City campus and you run around U Stadium. Muscles aren't stupid. They don't want the lactic acid building up either. So what they do, as soon as you start making it, they start pumping it. They pump it from the muscles into the blood. And maybe it takes 20 seconds because that's how long it takes a drop of blood to circulate the body. It gets taken up by the liver. We love the liver, and gets converted back to glucose. The liver actually uses liver fat, breaks it down using oxygen, converts that energy in the liver fat into ATP, which you use to convert the lactic acid back to glucose, and then pumps the glucose back into the blood. So you can actually recycle the lactic acid back into glucose. This is called the Cori cycle. Swimmers and wrestlers in boxers, when they're done exercising, their bodies are loaded in lactic acid. And when they go into their cool down period, where they can get their wind back, it gives the body a chance to pump all that lactic acid out of the muscles, go back to the liver, convert it back to glucose. Is this a perfect system? No. That's why many professional sports teams hire a masseuse or a masseur. He or she will literally work the muscle tissue, or they'll use machines, those kind of vibrating machines, to try to work as much lactic acid out of the muscles back in. It's going to happen naturally, but you're trying to speed the recovery process because it's Monday and it's the NFL, it's football, and you get practice on Tuesday. And so, anything that can speed this process up is what they're going to do. And I'm going to end on that.